A distributed application is an application where it is distributed. Means it's nothing but a set of applications or set of programs running distributedly, so that can be different machines or different places and anything. So before, people used to create a distributed applications using RPC based structures or message based structures. We have seen that RPC based are nothing but remote procedure call based. So it depends on the language we are using, and their technologies based on languages. So for example, if it is Java, they used RMI. If it is .NET, they have used .NET Remoting, DCOM, WCF, and also for C++ and other languages they have used Corba. Okay, we know that a program can talk to the same kind of program using these technologies. And there were also asynchronous based technologies like using message queues, and it is but asynchronous, and you have many problems with that because it's not synchronous first thing, and not only that, you have to convert it into a message, and message needs to be converted back into some other thing, and there is too much of conversion there. Okay, that is why people started moving more into web technologies, as web gave you a protocol to transfer information using hyper, either using HTML or XML. But HTML is more about presentation. We have seen that HTML is more about presentations like links, paragraphs, bolds, italicized, fonts, and everything. So when two applications are sharing information, they don't share presentation, they share only business. Someone will ask for a request, another person has to respond, so that will be business. So XML is suited well for web services. So nothing but they will use HTTP and XML. So one of the primary problems when using services, distributed applications using web services, security and performance. But over the years they have come through many phases, and they are very good with performance too. But you cannot always compare the performance to the same standard. Like for example, Java RMI, that is little bit faster when you compare to web service. Okay. So what are XML web services? A XML web service, generally a web application or a website. What is a web application or a website? Resources are hosted on a server. Resources are hosted on a server. It is hosted on my server. I am using URL and a HTTP protocol. See, web application or web service, web application or website. Okay, so what are you doing? A resource is hosted on a different machine, okay. You are using HTTP protocol and giving the URL to get the resource and post to the resource, right? You are going, so it is nothing but HTTP using HTTP protocol. And how do you identify the resource? Using URL. So resource is identified using URL. Resource is identified using URL. Okay, so similarly, but who is getting it for you? Browser. We are doing that on browser. So similarly, think like a resource is there. Okay, there on another machine, I can use HTTP to get that. Can a program use HTTP plus URL to request something, and the other application will respond using XML. Yes, we can do that. Simple. When browser is a program too, you are giving a HTTP request and the other person is giving HTML and it is displaying it. So two machines are communicating. Even web applications and websites are nothing but communication between two machines. There is another machine which is hosting this web application. You are just seeing through browser. Of course, you might say I am connected to internet, but it doesn't matter. You are connecting to another machine using HTTP protocol and giving a request and getting that. Similarly, you are passing a request. You are supplying information into, means you are passing request like please log me in, and you are passing this credential. So similarly, when two machines uses HTTP protocol and transfer XML between them using a URL, that is nothing but web services. Okay, web services. What are web services? Two programs communicating two programs communicating using the same technology. This one, HTTP, XML and URL, is nothing but a web service. So before, a Java program, instead of giving a Java request, it will give a HTTP request to another program. Katija is asking me, when do we do there is an ambiguity? What do we do if there is an ambiguity during a test? I can't answer that now because I'm in web services and I will get back to that. Please ask me later once I finish the recording. Okay. Yeah. So two programs are communicating using HTTP protocol and they are passing XML. They are passing XML using a URL. So when two programs, two applications communicate using these three things, it is called web services. Okay, got it? As simple as that. So you don't have a browser or anything. So if you see here, there will be web service and you will talk to the service, hosted it, and then you will the program can, whatever the result comes as XML, so you can modify it and you can display as you want. Okay. Pallavi is asking me, can I send a request using XML? I cannot send a request using XML. Request is XML. Understand? Request is inside XML, but I am sending it using HTTP protocol, using this URL. So request is XML. Request is XML. XML is a message. XML is the transfer message used to transfer between, for request, message for request and response. Okay, got it. All right. Agree. Let's see more. Okay. I will write some service oriented architecture. So let's see what is service oriented architecture means. What is SOA? Remember, people, we know that two applications needs to communicate. Two applications needs to communicate. Okay. Okay. For example, tomorrow you will go to some site where you want to purchase tickets. For example, you want to purchase some movie tickets or anything. Do you have to go to the movie theater website, or do you have to go to the theater nowadays? No. You can go to Fandango and you will purchase a ticket. When you purchase a ticket, really they have to submit the order to the theater. Do you understand? You have to submit an order to the theater. Agree? So finally, when you go to Fandango site and you purchase, so think like you go to Fandango and you will submit you will purchase 2 tickets. But which theater you are working for, which theater you are ordering for, like think like Century, somewhere in Fremont or something like. So they need to Fandango, when you submit the order, when you click that submit order, that needs to submit order on the Century theaters. Agreed? It needs to send a confirmation, or it needs to take out, because even the theater also people are buying this. So what I'm trying to get here is like applications communicate. See, Fandango application will communicate with Century application, or it can communicate with Regal theaters application, it can communicate with AMC theaters application. Two applications need to communicate. When applications are communicating, people are saying that do not architect haphazardly, or do not do ad hoc architectures. Don't do ad hoc architectures. So do not do ad hoc architectures. So when applications need to communicate, there is a Fandango is using AMC service, but Fandango is providing a service to you. I don't care. It might be end user, Fandango is providing a service to you. But what is happening? Fandango is using the service of what? AMC. For example, AMC said that AMC created a program everyone can use, all my vendors can use this program to buy tickets. Now Fandango became a vendor to AMC. It will call that program. So this guy, Fandango is the consumer. Fandango is the consumer, and AMC is the service provider. Why are people giving, see nowadays you can buy Comcast service from your apartment owner, you can buy it from your homeowner, you can buy it from, even though you go to a movie theater, they are saying that okay, we will give you offer with this, because people are integrating with other businesses. A business integrates with other businesses, then only there is more money. Like you get more customers when you integrate with other businesses too, right? So people, there is, see, before you need to get Comcast, you have to go to Comcast, but you don't need to go to Comcast. Even though you buy a movie ticket, sometimes you get an offer on Comcast. They are making it in. See, selling is more important. You need to sell. This is all, this communication, SOVA architecture, distributed applications is B2B, business to business applications, business to business applications, business to business. By when you provide, when you integrate your business with other business, your business will grow. As simple as that, right? When you integrate your business with the other's business, your business will grow, because you are reaching more audience. You are reaching more audience. So then you can do more sales. Simple. So Fandango here is the consumer. AMC is the service provider. So even though it is between companies, even though it is internal company, intra company, or it is intercompany, for example, for Citigroup, inside Citigroup only there are many applications which talk to other applications. So architect it in such a way that one is service provider, and one is consumer who consumes the service. Hold on one second. So the architecture is, when you lay out this architecture, you should provide a service application. He is the service provider, and this guy is a consumer. Consumer sends the request, service provider only responds. Service provider only get the request and response. So when you lay your architecture like this, this is called SOVA architecture. So create applications which are service oriented. See, people try to create many applications and each talking to other. Don't do that. Who first identify what is the service and make an application that is a service application. Identify consumers. So identify how your consumer should send you a request, and identify how you should send the response. So when you make these applications, you are creating a structure in your company. So this is called service architecture. Sometimes there will be brokers also. For example, if you want to buy a BART ticket or something, of course you have to go to BART or you have to go to some other sites. Sometimes brokers are also such, there are some other brokers. So sometimes there are brokers, but nowadays brokers are not there. So you should lay out in such a way that there will be a provider, there will be a consumer, service provider, there will be a consumer, there will be brokers. When you lay out, these are programs, everything is a software program there. Provider is a software program, consumer is a software program, brokers are also software programs. So when you lay out your architecture of your distributed applications like this, that is called SOVA architecture, service oriented architecture. So Anuradha is telling me that SOVA is nothing but a relationship between a consumer and provider. No, SOVA is laying out your applications in such a way that don't make monolithic applications, single applications or something like that. Lay out your applications in such a way that one is provider, one is consumer, maybe there might be a broker. So when you lay out, when you design, when you architect your solutions like this, that is called, when you design, when you architect is, that is but service oriented architecture. Alright. And Cyclen is telling that, for example, Nexus providing credit scores to financial service providers and insurance companies instead of credit bureaus directly. Yes, you can do that, but I am talking about here softwares, especially when you're designing an application, you're talking about really businesses outside. I don't want to talk about businesses outside. I want to talk about softwares. Okay, a software used by another software. Okay. Pallavi is asking me, can your application be both provider and consumer as well? Yes, it can be. Yes, very good question, Pallavi. This service provider might be consumer to another provider, right? This service provider may be a consumer to another provider, but don't create that many layers, because if there are too many dependencies, the architecture is not stable. If there are too many dependencies, the architecture is not stable. Okay, that is the reason they are saying service provider, consumer, got it? But you can do that. Geeta is telling that when I purchase on Amazon, the card validation is done by another company. Yes, that is a service provider. Yes, MasterCard, Visa and all provide a service to validate the credit card. Yes, every application uses that as a service, and these are consumers. Yes, perfect. Gateways, merchant services, perfect. Gateway services. Alright. Geeta is asking me that can a service provider and consumer programs interchange their roles? Then there is something really wrong with that, your design. When a provider is becoming a consumer and consumer is becoming a provider, there is something really wrong with your application. Good thought, but see, means you had a bad design there. Okay. All right. Let's go further. What is a broker? There is a question about what is a broker. Do not worry, I will come there. Everything is explained. Okay. So people will ask, is SOVA means web services? No. Web services are one of the way to implement SOVA, but that doesn't mean web services are the only SOVA way. SOVA can be done by using Java, RMI, Corba, anything, any distributed applications when you lay out it SOVA. But that doesn't mean SOVA means distributed services, distributed applications means laid out in this architecture. So that doesn't have to be web services. Okay. Alright, so SOVA cleanly partitions and consistently represent business services. It is laying out, dividing the services. It means it is dividing the functionality so that who is a service provider, who is a consumer. SOVA is a fundamental change in a way we do business. Service oriented context for business logic. When you do applications, you are writing, means who is the provider, who is the consumer. So you are dividing the logic, you are dividing the infrastructure, you are dividing the software environment based on this business architecture. So what is the idea behind SOVA? Remember this, you will be hearing this in programming or in development or designing. When you are designing, if you become a designer, you will hear this concept a lot. Loosely coupled, tightly binded. Loosely coupled and tightly binded. So when you make softwares, you should use this tightly. I do not know if the spelling is wrong. Tightly binded. Okay. So what does this mean? Loosely coupled means the coupling between the application should not be tight. It should be very loose. For example, if the service provider is done, I am not depending on the service provider. I am using service provider. There is a strong difference between both of them. If I am dependent on service provider, I cannot run my application. I cannot even start the application without the service provider. I cannot even give a user feedback. I cannot even do, means if the Fandango, for example, if the AMC service is down, Fandango site will not be down. Do you see that? That is the difference. So that they are loosely coupled but tightly binded. Binded means if you submit a AMC order, it has to be a tight association using web services or some other protocol. So that is tightly binded. Even though they are loosely coupled, they should be tightly binded. Okay. So that is the thing. Loosely coupled, tightly binded is the idea behind making SOVA based application. So someone is asking me like, is SOVA made by developers? No, SOVA is architected by your architect, means the architecture is made by the architect. Coding is done by developers. Testing is done by testers. Same. This is how we do applications. SOVA tells how we do application. It doesn't tell you. It tells everything. How to design. And when you design, the design automatically affects coding. If the coding is affected, when the design changes, testing also changes. Before you only see from a web application, but now when I'm doing Fandango and AMC, you have to play with the service provider, you have to play with the consumer, you have to play the integration. Integration testing comes there. Got it? So it's all depends. When you do integration testing, that is protocol based testing. What is the protocol used for this coupling? That is HTTP. So you need to do HTTP testing. It depends. Rashmi is asking me like who will test this? Who means by provider company or consumer company? When a provider is providing something, he will already test it. His company will already test it, then only release it. If a provider is releasing a service, he already tested it. So even though there are no consumers, people in their company will create a dummy consumers to do the testing. Got it? And if a consumer is using it, he has to test the how he is consuming. He has to test the provider, means how the consuming is taking care of this one. Sam is asking, if AMC is down, can you still buy tickets from Fandango from AMC? Okay, loosely coupling means doesn't mean that you can buy. I said that the Fandango site will not be down. If AMC service is down, will the Fandango site will be down? No, loose coupling is there. Not when you're talking about ordering, when you buy a ticket from Fandango, if AMC is down, they will tell that right now we are not doing AMCs, or can you come back, or they will take the order, but they won't send you the confirmation email. They will only send the confirmation email when the provider is up and they made the order, and they send you the confirmation email. There are many ways to deal that. That is all in your design. That is all your architecture has to take care of. Divas is asking me, what if we have to test for some apps for service provider? In that case also should it be loosely? Yes, service oriented architecture is based on loosely coupled. Means when there is service oriented architecture, that means loose coupling is there. As simple as that. Yes, you have to test it. How we test it and everything, please give me some time. We'll get there. Agreed? Alright. Otherwise I won't get enough to cover today. Alright. So it's a contractual thing. See, it is making a contract. Means Fandango, and remember AMC will say that it will charge Fandango like for example monthly $1,000. Got it? Contract. If this guy doesn't pay next month $1,000, they will cut that service. They will say that we won't provide you the service. They have this contractual base. Means you are laying out nice architecture so you can implement contracts. And autonomous, each business entity is individual, but autonomous, but at the same time they are communicating. Okay, and abstract means Fandango will never tell you how, means you will never see how Fandango really did make purchase a ticket for AMC for you. Abstraction, reusability. By making AMC this one service, he can sell it to Fandango, he can sell it to some other site, he can sell it to, so he is making this reusable components. He can also use the same service, at the theater counter too. The theater counter terminal will just connect to this service to make tickets too. Got it? So one service reusable. So don't make web applications. When you think that there is a web application, don't think that logic is on the web application. It might be on a service, Java service, but this web application might be talking to that using web services. You never know. Because think like if AMC made that service, even AMC wants to use that from its web portal, from its iPhone apps, from its counters at the theater. So because they don't want to write this code again and again for everything, right? They make one service, they will sell it outside, they will use it for their own web application, they will use it for their own theater counters, they will use it for their own iPhone apps and other apps. So reusability, what is that application? Does it have a user interface? It will never have a user interface. It is a Java application or a .NET application or anything. But how is this web application talking to that? Using web services. Got it? So that is the reason why I am taking reusability. Very good. Got it? And composable, stateless, discoverable. Okay, you read it. So potential benefits. When you lay out SOA architecture, not only that, when you lay out SOA using web services, we are based on open standards, means we are based on HTTP XML. This is global. No one owns it. Microsoft doesn't own it, or Oracle doesn't own it. Who owns XML and HTTP. Can anyone tell me who owns it? Which company owns XML and HTTP? XML, HTTP, CSS, HTML, whatever it is, HTML5, XPath, who owns it? W3C, World Wide Web Consortium. It's not W3 Schools. W3 Schools is a site to learn it. W3C Consortium. It is a combination of many companies. On the board of that, there will be a person from Microsoft, there will be a person from Oracle, there will be a person from every company. Even there are persons from W3 itself. W3C, World Wide Web Consortium. They make the standards for web. It is not owned by any company. Alright. Very good. So, supports vendor diversity, fosters intrinsic interoperability. Please read this because it's more of theory. You can, what are the advantages of SOVA? Yes, these are the ones. Okay. Alright. So, if you see this diagram, it might look very complex, but all you need to see is people are exchanging messages. Do you see this message? This is a message, this is a message, this is a message. And for example, there is a consumer, and there is a web service, bank web service. But how it is talking to the web service? It goes and puts something inside this one. Okay, there is electronics funds transfer web service. I want to transfer funds to some other person. Say for example, I am a consumer, I want to transfer funds from one person to another person. So I send that request. This request actually goes to UDDI because this guy doesn't know. Okay, let me tell you one thing before this one. I want to do this. Sometimes Fandango directly connects to AMC. For example, think like Fandango wants to connect to AMC. So Fandango should know the service, about the service. So think like it will go and talk to AMC, and AMC will say this is how you have to connect and this is how you have to pay, and this is. So Fandango is directly talking to service provider. But think like AMC gave all these services to IBM. IBM is the broker. IBM UDDI is the broker. IBM is the broker. Now Fandango has to talk to IBM. So this guy is the broker. So to connect to AMC, you need to go to IBM and this one. Okay. So IBM exposes this service. IBM exposes the service, but it is actually connecting to the AMC service. IBM is exposing the service, but it is connecting to actually AMC service. Alright. So let's see now. Think like I'm a consumer. Think like I'm a Fandango. I want to buy a ticket from AMC. Let's see this one. I want to buy a ticket from AMC. So I will put a request to this web service. But this web service do not know where it is. So it will go to IBM server. It will go to IBM server and gets that where is the AMC server. Oh, it gives the address. Okay, I know where is the AMC server now. It will go to AMC server and gives this, please purchase me this ticket. Okay, this guy says ticket purchased. And he has to do some payment, or for example taxes and something, it needs to take a commission or something, so it goes to that person, another service, and this guy reduces he takes some small fees and everything, and he sends back, and we know the exact total now, and we come back here. Do you see that? It might look simple, it might be looking complex, but if you have a business case, it's very easy. Fandango wants to buy a ticket from AMC. So it hits the IBM web service. IBM web service means it is the web service for all the services. It goes to UDDI repository, gets the address and goes to the AMC, buys the ticket, Okay. So see this one. Fandango, we are putting an order for a ticket. For example, think like it might be a IMAX, or it might be a normal theater ticket, or it might be a 3D movie ticket, we don't know. So we go there and we submit a request for ticket. This IBM service do not know where there is. They are putting a registry. They are putting a registry which maintains all this list of services. So this request automatically takes us to this one. Oh, AMC, where is the AMC? Where should I purchase the ticket from AMC? This guy sends it. This is all IBM. Both of them are on the IBM side. My request went to IBM. IBM internally sent it to registry. Registry sent back that, oh, this is the place where you are to. And I got the address of the AMC. Now I go to AMC and submit the order. Submit the order. But what this guy does? This guy takes it to micro payment. Like for example, taxes and other things are calculated here. For example, if it is a IMAX service charge and if it is a 3D movie, some other charges, then I will come back here with my ticket confirmed, with my taxes and price confirmed. I will come here. Then it will come back to me with the total. This is the Fandango. What is UDDI? Please don't ask me now. I will explain it. So Divas is asking me if it is, so who is the broker now? Yeah, IBM is the broker. IBM is the broker. Okay. So remember, there is no direct way to connect to AMC. So IBM provided this movie ticket service. So you send a request to that, please buy me tickets for AMC. Please buy me tickets for AMC. 2 tickets for AMC. Okay, IBM not only sells it for AMC, he is a broker for many guys. When there is a broker doesn't brokerage for one service provider. He will do that service providing for many services. So he will go into his database, registry database, and he sees that, okay, AMC, where is this guy? He will get the address, URL for that guy, comes here, back. And he will redirect it to AMC. This guy will go to AMC. And AMC, inside the AMC, you purchase the ticket, but you need to calculate the service charges, taxes and everything. So it will go to these taxes and some other thing. Okay. And it will come back here. It will come back here. The broker will pass it back to you. Fandango. So you got tickets, 2 tickets. Let's go to movie. So now you understand? All right. Okay. So if you see here, service oriented architecture involves 3 things. One is service provider, one is broker, one is consumer. So when you are using web services, web services are hosted on a web server, Apache, IIS, Tomcat, of course, Apache Tomcat, JBoss, and whatever it is. Okay. So WebSphere, WebLogic, and there are many others too. So web service means a web service can be hosted only on web server. Got it? Like your web application is hosted on web server, a web service is also hosted on web server. So I hosted this. This is the server. It is ready. Gita is confirming one thing. So all this is happening through HTTP and XML. Yes, HTTP and XML only. Everything is happening using HTTP. That is, when you do it using HTTP and XML, it is web service. If you don't do it, there are other services. It doesn't mean that I have to do that way. SOA doesn't tell that you have to do that way. SOA doesn't tell it you have to do that way. It's up to you. But you have to design your applications like that. But if I use that SOA, this is web services now. I want to write this as a web service. So now, if you want to do SOA using web services, okay. So if you are using web services, what is the first rule? You have to use HTTP, you have to use XML. But this guy says SOAP. Let's see, let's wait until we get to SOAP. So we have web service, which is hosted on a web server. We have SOAP, we have a client, and broker is called UDDI. Why is broker called UDDI? Wait for 5 minutes. Okay. So SOA means service provider will publish the service. Broker will bind this service to consumer, will find it using broker. Broker will bind a service to Broker will bind a service to consumer. Broker's job is to bind. Consumer's job is to find. Service provider's job is to publish. You see, and internet is there. This is SOA using web services. Okay, if you see this one, that is why now if as we are using internet, what are we using? The protocol HTTP. So how do we do that? Using XML web service consumer, XML web service provider, XML web service broker. Okay. So in any SOA architecture, you will have provider, consumer, broker. If it is web service consumer, web service broker, web service provider. Okay, and web server provider should be hosted on web servers. What are some of the web servers? Like for example, Apache Tomcat, IIS. These are all web server programs, and IIS and WebLogic, WebSphere, okay, WebSphere, and maybe JBoss too. Okay, JBoss is more of application, but it's okay. All right, so you don't need to have this one. So they are all based on what? Like they are based on .NET. Means IIS is based on .NET, Apache is before Java, and for example you can have like Zend, Ruby on Rails. You can also have like PHP and all this stuff too. So Zend engine, PHP is Zend engine. I don't want to go into deep. You don't have to know this. It's okay. Or Ruby on Rails, some other, any framework. Okay. So examples for web services providers, I already have given you many, like ticket sales. Okay, ticket sales, any sales using vendor, any sales using vendors. Okay, all right, got it. Most of them they are service variant. All right, not now. Okay, let's go this one. First thing you need in a service oriented architecture is service. If there is no service, nothing is there. There is no broker, there is no. Salim is asking, can we use Suleka? Yes, we can use Suleka as example too. Yes. Alright. So when we say this one, like for example, when you come with like what are the artifacts of service oriented architecture? First you need a service. Service needs to have visibility, interaction, real world effect. Means service is really giving you some real world things. See, it is providing ticket sales. It is giving me tickets for movies, right? It needs to have a real world effect. It can interact with consumers or brokers. It should be able to interact. It should be visible. How it is visible? Using URL. And how it is giving a real world effect? It is delivering something. How it is interacting? Using XML. Got it? Right. So what is a consumer? Consumer is more of who just uses it. He is dependent on the provider. So consumer is more dependent on the provider with minimum functionality, service location. Like he only needs to know what is my provider giving me, where is he, some proxies, asynchronous calls. I don't want to go there. Please, it's okay. You don't have to go that deeper. It's okay. You can learn all this later. Alright. So some of the consumers are like I told you, Fandango, Citigroup, for example, credit card loan application and some other things. Okay. So broker is sometimes necessary. Broker may be necessary, not necessary. He is the one of the optional guy. People used to use a lot of brokers when actually web services movement started like 6 years back. But nowadays no one is trying to prefer to use a broker. And here broker means not a real broker. It is a software too. So too much of dependencies are killing applications. So people are not willing to put brokers, and brokers are nothing but UDDI registries. What are UDDI registries? Let's see. UDDI registry means UDDI. Universal or uniform, I don't know. Universal discovery, description and integration. Okay. See, A UDDI is a broker. Broker means broker lets you discover, lets consumer discover a service. Okay. A broker provides description of the service. Then he will integrate. I don't want to use he. Broker will integrate then integrate a consumer to a provider, to a service. See, simple, as simple as that. Broker repository, these are called UDDI registries. Famous companies like big companies like Microsoft, IBM, Oracle, they created huge repositories where everyone can, for example, I created a service. For example, I created one of the most amazing service. Think like if you can do mathematics functions. Think like that service is nowhere provided. You have to, for example, you want to do complex math calculations, you want to use my service. I am providing that service. But how do I sell myself? Can I sell myself? I don't have a marketing team or anything. So what would I say? I will go to a big company and say that, can you be my broker? Can I put my service with you? Oh, he will say that, okay, put me, I will create, and he will create me an entry inside this UDDI registries, and you are there. So when people like, for example, so think like you are working on some mathematical problem and you want to find if anyone is providing the service, you won't come to me, no, right? Because you do not know me. What will you do? You will go to the companies like Microsoft, IBM and Oracle, and you will go to this UDDI repositories. And you will search for there. That is called discovering. When you search, what will you get? You will get a description. Oh, this service URL is this one. He charges this much for each connection or something. So he will provide you a description. Okay, he will provide you a description. UDDI repositories are only listing the services so that people can discover services. It is providing a communication. It's like a board. It's like a Google search. As simple as that. Okay. So UDDI repositories are providing a link between, yes, like Yellow Pages. Very good, Ramnath. They are providing a thing. But they take a small commission for that, and you can put your service, you can put where it is hosted and how to integrate. So it lets you discover, it lets you describe, it lets you integrate. Those are brokers, UDDI brokers. So UDDI brokers, universal discovery, description and integration of services. Nowadays no one uses this. No one uses this. Trust me. And remember, this UDDIs means if you supply a program, a UDDI, it will go and search for what it wants and then it integrates. Everything is happening in the program. Don't think that you are doing it. Everything. UDDIs are not human readable. They are machine readable repositories. I forgot to mention machine readable repositories. So it is not for you to read. It's for the machine to read. Programs to read. Repositories. Programs can find services. So coming back to this one. So UDDI is nothing but a collection of specifications like XML specifications. They are machine readable, and UDDIs will have like 4. Even UDDIs are nothing but files of XML. Every service is nothing but a XML. Inside that XML there is a business entity, business service, business template, publisher assertion, T model, something. You don't have to really go into this. Trust me, they are not used. Yeah. So what is XML? As I told you, XML is created after HTML. Got it? So if you see what does this mean is like, if you see a HTML document, what is the root tag? HTML means mentioning this is a HTML document, and then you will have a end tag HTML. All the hypertext will have a begin tag or end tag, right? Begin tag and end tag. So if you also look at this one, there will be a head tag, right? Inside the head you can have title, meta tags and other things like a script or anything, and you will have a body, right? You will have a body. This is laying out the structure. So if you look at the tags of HTML, lay out the structure, okay? First, HTML basic elements, okay? Lay out the structure, like for example tables or anything. Formatting the data, and styling bold and all this, styling it. So it's more about presentation. See, basic elements telling that it is a HTML document, and telling what is the layout, any scripts used, formatting the data, then styling the data, and you will have attributes. For example, I have a paragraph, and I will put something like okay, paragraph, and I will say welcome to, welcome to whiteboxqa.com. Got it? This kind of stuff. So if you want to see a real XML, real HTML, let's go to this one, whiteboxqa.com. Even though I wrote it in PHP, it is HTML only. So if you go and see, okay, alright. If you go and see view page source, if you see this one, always okay, and go page source, see HTML. There is XML namespace. Don't ask me what it is right now, because it is a XHTML. I know that, but I wrote XHTML, not HTML. Let's see that. And if you come here, there is a header tag. Inside the header there is a title. This is the title for the page. Then there is a meta tag. And there is another meta tag. This is a content type. This is content. What is the content? Meta description tag. And I am calling two style sheets here. I am using two style sheets. Then I am calling two JavaScript programs like JavaScript files, jQuery function, jQuery, and other thing. This is all in header. Then if you come to the body, there is another JavaScript function also. Forget about it. That is to disable the right click. And if you see the body, I put a div, and this is the navigational unordered list. I put a navigational unordered list. Got it? And if you see, then I have a support, and then I have this main content. If you see, this is where I started main content, another div, another paragraph, and I wrote this content, divs and everything. I didn't use tables, but I used mostly CSS and divs and stuff. I have some object. If you see object type, this is like a more of a flash object. This is like more of a flash object. I used flash object here, and I use this one. So HTML contains basic structure elements and layout elements, formatting, styling, and other things too. So for example, the beauty of HTML means I wrote body and I forgot body. Is that okay? The beauty of HTML? It's okay. It means it's not strict at all. HTML is not strict. Okay. Browser will understand. Oh, he forgot the body end tag, and it will put it. And is it a case sensitive? If I write HTML smaller or it is HTML bigger, does it matter to you? Does it matter? It is case insensitive. So remember that, case insensitive. Okay, alright. So it is more of a case insensitive. So, and it is not strict and everything. And more about presentation. Alright. Okay, agreed. So this is the one. But what happened is these are all predefined tags. Another thing, predefined tags. Who defined these tags? Can anyone tell me who defined this? HTML, head, body, HTML, and HTML also has versions. What is the current version? Predefined tags and attributes. Attributes are nothing but values on the tag. For example, if it is a link, remember link, how will I use a? And attribute href is an attribute. Href is equal to, let's say, selenium.php. Remember, this is a is a tag. You can close a tag like just like this also. You don't need to have an end tag. You can close like this too. You can close like this. See, a href attribute. So predefined tags and attributes. Who defined the attributes and tags of HTML? W3C. Okay, yes, I agree, but Tim defined it, but now it's maintained by W3C. It's maintained by W3C. What is the current version of HTML? HTML5. It's a beautiful HTML. All about objects. More object tags are there. Everything is about objects. A video can be an object. Like for example, a presentation, anything can be an object. Object embedding is focused more on. Objects are more focused on version 5. Objects are more focused on version 5. Okay, objects. Alright, so you don't need to use Flash at all. That is the fight between iPhone and Adobe, if you know that. Okay, alright, so now let's look at some other thing. This is all predefined and this is the one. But remember, HTTP is a protocol to transfer hypertext. To transfer hypertext. Agreed? To transfer hypertext. Does it needs to be HTML? No. Right? Because if I want to send you a message, hello, how are you? Something like that. Do I need this HTML body, paragraph and all these things? Do I need it really? No, I don't need it. I want to send it using HTTP protocol. Then what should I use? That is the reason he created XML, extensible markup language. Extensible markup language. So the tags are user defined. Means the user who is writing this, it is between user defined. XML is not about presentation. XML is about communication between two parties. Means communication, message. It's a message. It's about a message to communicate between two parties. Got it? Agreed? 1 second. I need to see something. Alright, to communication between two parties. So XML is about a message to communicate. So when I am communicating with you, see, for example, if I want to write a letter to you, it's up to me and you. There is no standard format or anything. I know there are some standard formats, but if I want to convey something to you, the two people talking on phone is different to each other. Every communication is different. Communication is between those two parties. You cannot define communication. Do you see that? That is why XML never tried to define the tags, because it is between the two parties. I don't care. But all I can say, the message format, all I can say about message format only. I cannot tell more about communication. I can only tell message format. So in an XML document, you should start with XML. You should have a version. You should have a namespace too. Alright, then done. Whatever you write, it should be in tags. Whatever you write should be in tags. For example, I want to send a note to you. Okay. My note. I'm telling that. Okay. My note. Got it? Agreed? My note. And I will say that, hello, how are you? Okay. You see this one. The tag determines what is the business. What is that business entity or attribute it is representing? Yes, I will come there. Do not go too faster. XML is case sensitive, not case insensitive. Okay. So when I am coming there, do not disturb me for a couple of minutes. So when I am writing the tags identify what is the business, but what is inside the tag is the business communication. Identifying the communication tags and communication. For example, I am sending that. Okay, priority. I want to send this priority of this node. Priority. Okay, all right. Okay, priority high. I will tell that this is a high priority. Okay, so I will tell that, and I will send you this message. I will send it to how will I send it? For example, think like you created a web application for yourself. For example, think like Pallavi created a message site for herself, pallavi.com, and send me message .php. Okay, .php, .asp, whatever it is, I don't care. Now I will do a post operation, and I pass this into this URL. You will get that message. You have to write your own program on the other side to get this message. but you will know that I am so the signature of this document we should share. Communication means how I am communicating is between you and me, right? How I am communicating with you is between you and me. So you should already know how I am going to communicate with you. Got it? Agreed? So when you look at this one, so I will do a post operation, I will do a HTTP post operation too, I will send this message. But she is anticipating this format because I shared this format with her, because we know that, okay, I am going to send this message to her, so she will anticipate the format of the message. But it is between who determined this tags priority, my note, me and Pallavi determined. Or Pallavi might determine, I am using that, because it is her messages, so she can tell that this is what the way I want my messages. Do you see that? Okay, so that is more about, yes. So this format, messaging format or the message type means it is anticipated by the receiver, because we share it the format before only, or you can find out the format by reading that too. So this is about XML. But coming to XML, XML is case sensitive. XML is case sensitive. Means if I say my note and I can also have one more tag, I can have one more tag, capital my note, like but this both are different. And if you don't, XML is strict. If you don't close it, this message will fail. XML is strict. XML is strict. And another thing, tags are user defined. Tags are user defined. Got it? And what else? Did I mention something about this one? Okay, and who maintain the standards for this one? W3C only. Everything is W3C only. It is more about communication, more about business or data No presentation at all. No presentation at all. Okay, all right. Yes, it's more about communication. Agreed? Very good. So now coming back. So what does XML contain? XML is a tree, not a forest. I read this from W3 schools only, but it is one of the most beautiful quote I have ever came across. Because remember, tree is a organized structure. Forest is not an organized structure. Tree means, for example, you can identify every leaf on a tree. For example, I want to go into like some leaf. I will say that start at the root and go to the first branch from there, and go to the second child branch from there, and go to the third child branch from there, and the fourth leaf is the leaf you wanted, or the fruit you wanted, or something you wanted. Do you see that? Tree is a very organized structure. Every path is unique. The quote is, XML is a tree, not a forest. XML is a tree, not a forest. Okay. Forest is very unorganized structure. Can you tell how to get to one tree in a forest? You can't. Okay. Even though you say that might be changed. Okay. But tree is a organized structure. Forest is not. Tree is a organized structure. Okay. So coming to if they are well formatted document, they are organized structure. Everything, there is a root. There should be first root element. XML is all about elements. What are elements in XML? XML means, for example, actually I wrote my XML very wrong. If you have seen this XML is a very bad XML. For example, why means XML should start with always a root node. Means everything inside one node. That is called, for example, root node. For example, my message. Do you see this one? My message. Do you see this one? And you should close this one. Everything is inside the root node. This is called root element. Nodes are elements. Got it? Nodes are element. Let's remove this one. Okay. Alright. So this root node, everything starts with the root node or root element. Okay. Element is something which starts which closes and something is inside between them. So there are two kinds of elements, root element and child elements. I know that there are two kinds of elements divided. One is called simple elements, and another one is called complex elements, What is the difference between a simple element and a complex element? Simple element is simple, complex element is complex. But how it is complex? Complex element have child elements. Any element which has child elements is called a complex element. And simple element, no child elements. Okay, we become complex. You know that, right? Yeah. Tell me what are the simple elements and the complex elements here. In this XML, tell me what is the simple, tell me how many simple elements are there, tell me how many complex elements are there. Tell me. Don't tell me 1, 2, tell me the node name. There is a element means there is a element name. Don't tell me 1, 2, 3, 4. No, there is no 1, 2, 3, 4 in XML. My message is a complex element. Priority is a simple element. See, element is something which starts and this is not an element. This is a data inside an element. My message is a complex element because it has two child elements. Priority and my note are simple elements. Perfect. Alright. Agreed. So now come back. So this is elements and complex. There are something called attributes too. There are something else called attributes. What are attributes? What are attributes on XML? Let's say attribute is nothing but an element. It is a property on an element. For example, my message. For example, I will say my message date. Do you see this one? Date is equal to 02/29. Remember this date. I do not know if I will write this again. Very soon. Not again. Very soon. Yeah. So 02/29/2012. Okay. So my message date. Date means the date. See, this is not an element. This is a attribute on an element. This is a attribute. Date is an attribute. Date is an attribute on my message element. Got it? Remember that? Alright. So there is always actually a fight when whoever is designing the XML, there is a strong question, should I make it an attribute or element? When should you make something a attribute or a child element? Okay, or element. Means when should I go for an attribute? See, priority, I can use priority also here instead of writing here. So should I make a priority an element or an attribute? So how do you define that? How do you determine that? When to make attributes, what to make attributes, and when should you go for an element? How do you define? Anyone can you answer this one? This is the biggest challenge anyone who works on XML faces, means creates an XML faces. Anyone? There is a shortcut for that. Attributes, even element has a value. So there is something like Rajita is telling me that attribute has a value. Of course, priority also has a value, date also has a value. It doesn't matter. No, I am not seeing a answer which I am looking for. Account number cannot be attribute. No. When something, remember this, attribute. When something has predefined set of values, you should use attribute. When something you do not know what can be put in there, anything, it's universal, I don't know, I can't control it. The scope of a thing is, when the scope of the business is not predefined. For example, how would you say predefined or not? I will tell you. Predefined. Date means there are only set of values you have to pick from. You cannot say date and you can put anything you want, right? You have to select the values from the current date or date before or something like that. So date. Priority also, you can say in your company, priority means either low, medium, high, medium, high. These are the three priorities in your company. So when you do this priority should be an attribute, not an element, because it comes from a predefined set of, means this is not a guarantee, but if you are facing this problem tomorrow, I am giving a shortcut. So anything which comes from a predefined value should be a attribute on the node, whichever where you are. This one is high. See my node, and when you come to my node, actual the message of it, can you control what you can write in it? Nothing. It cannot be predefined. So that is why it is an element. Anything comes from a predefined set of values, like gender, like date, like priorities, like level, like something predefined business, come a set of values. Got it? So this can be attributes, and this can be elements. All right. So that is where elements and other things comes, and we have to look at something called now XML schema.